Welcome everyone to Developers Meeting on Sunday the 25th of June 2023. We are talking right now about the creation of our scientific advisory board, and I give the word to Jannik to introduce us to their way of creating papers and publishing and so forth.
Okay, so let me share my screen, maybe. This one. Oh yeah, I think, do you see overleaf now?
Yes.
Okay.
Yes.
So yeah, Richard suggested that we should have a scientific advisory board, and this should include, I think, external scientists, I believe.
Mm-hmm.
Is that correct? I think we in the separate Discord chat, we talked about also including external scientists, but also start writing scientific papers about the developments here at Sky 360. And we also talked about the overall strategy that we want to have. And I think we came to the conclusion that we want to have a more of a general first paper that describes the major features of our Sky 360 station and capabilities. And from there, break out some specific topics that we can present. For example, our machine learning approaches, how to detect and identify anomalous objects. And I think this is a good approach. And I started. Then we also talked about a possible journal where we can publish that, and then we just looked at what the Galileo project, for example, where they publish, and one of the journals where they publish is this Journal of Astronomical Instrumentation. And so we thought, why not try that? It has a rather low impact factor, so that is a parameter that we always look at as scientists, and this tells us how many times a paper was cited in that journal on average in 3 or 5 years. And this journal has an impact factor of 1.5 or so. That's pretty low, and that's normally telling us that the entry barrier for this journal might be a little lower than for other journals. This does not have to be the case, always the case, but the trend is that, yeah, this could be the case at least. And so we thought, why not try this journal? And I think David is also a scientist, and it seems like he also agreed to that, I believe. So, but we can, of course, always still change that target journal, let's say, where we want to submit. And what I did then is I got the template of that journal and just implemented that here in Overleaf, the template. And what I did now is just a first suggestion about the title that this paper could have. And the title is, I hope you can read that. I'm just trying to increase the font size here, but it's not really working. I can increase the font size.
At least for me, it's okay. Can you guys see
the code? Okay. So the title is here on the right.
Yeah.
And I called it Development and Performance Characteristics of a New Citizen Science Modular and Automated Sky Monitoring Station for Unidentified Aerial Phenomena Detection. So this is quite a long title, actually. And we can definitely debate if we want to shorten that a little bit. But I think it contains everything, all the features of the station that we develop, all the important stuff, basically. So I think that could be a nice title, but we can, of course, change that. And then, of course, we have to talk about all the authors. So my suggestion would be that we put everyone who is on the team here in the author list. But that, of course, also requires that the team members are fine that their full name is mentioned there. So, yeah, but for everyone for who this is the case, we can, of course, do that. And I think this would be a fair approach because everyone on the team is contributing to this station. So we should have everyone mentioned there, I think.
Absolutely.
Yeah. And then we would need to think about the affiliations of our team members. I would say everyone would be affiliated with Sky 360. Although, I mean, officially or strictly speaking, this is not really the case, right? We are not official, the developers are not official members of the Sky 360. What is it, a foundation or
An association.
non-association?
And
Yeah. So
this is not quite correct, Jannik. You are a
okay.
supporting member of Sky 360. Did you
Okay.
know that?
Yeah, right. Yeah.
Without
That's true.
obligations,
I mean,
there's no fees involved.
Okay. That's good. But I didn't know if I was on like
we don't
I
have
don't know
we do not have a
on an
payroll.
official member list or something like that.
There is.
Yeah.
There is.
There is?
Yes.
Okay.
But it's
Okay.
let's say it's official towards our authorities in Austria. It's not. We didn't publish it because.
Okay.
Yeah, there's. I mean, we have a list of 32 supporting members, and
Okay.
we kept it, let's say, as private as possible because some might say, I do not want to make that public, that anyone knows that I'm affiliated with those. So it's not an automatism, meaning when you are a developer with Sky 360, you become a supporting member. We need that tag because that allows us to send you hardware. Otherwise, we would send hardware to someone who is not affiliated with us. So there need to be affiliation. And the lowest means of affiliation was the supporting member.
Okay. Yeah.
So yes, you are affiliated with
Okay.
Sky 360 already. But it's not public.
Good.
If you want to make it public, we can do that. Which is
Yeah.
the paper.
I don't. Yeah. Right. But so when the names of our members are mentioned here, then of course it's going to be public, at least if we get our paper published. I mean, that's not guaranteed, but of course we will try. And then the second thing is, if anyone wants to have another affiliation, of course that would also be possible, right? So the more university affiliations we could gather, the better, I would say. But I would need to debate that. At least if I want to do that, in my case, I would need to debate that with my lab head. And yeah, I don't know if I want to do that in my current situation. At least, I think you want to be tenured, at least, so that, you have a position where you can't get fired easily, let's say. And then you're in a better position to do that.
Absolutely.
But in any case, that would be favorable, I guess. And if we have any members who have affiliations with some kind of astrophysical institutions, then this would be a major plus, I would say. But yeah. Okay, that could be mentioned here, and then we can go.
Wait a second,
Yeah.
Jannik. David just dropped in. David, can you hear us?
Okay.
David? Ah, there he is. Can you hear us, David?
Can you hear me?
Yes, now I can hear you.
Yeah, sorry, it's just a flying visit. I'm just away on holiday at the moment, so it's pretty noisy out. I'm outside, so
Ah,
just
okay.
listen again. Yeah,
Okay. So we were at the moment we were talking about the science advisory board and the first paper and the structure, how it shall look like, and what can be done and what not. And Jannik is, I hope you get the point why we talk about that right now.
yeah, it sounds good. Sounds
Okay.
good.
All right.
Looking forward to working on it with you.
Okay. Great. Cool.
Okay, nice. Yeah.
Great.
Yeah. So maybe we can go on with the structure of the paper that I have a suggestion for here. So that's, yeah, typically you start with an introduction, of course. Then I would have a section on the motivation for that describes why we want to build the station or have built that station when we publish it. Then a section on theory. So I just started writing something a little bit about what I think is necessary. So this paper, Waters et al., has a very nice section where they define different terms. And I think we can just use
Adopt.
these definitions. We of course, there has to be much more in that section. And then I would have a subsection which is called Anomaly Detection, where we describe what an anomaly is for us. That is something we could debate, of course, and of course everyone is should feel free to work on that also. I don't know if we want to go into detail here. It's just a small passage which I started to write.
Okay.
And there might be more subsections, but I haven't come up with any more than that up to now. Then we have a section that's called System Overview, where we describe the hardware and software. And for the hardware, I'm not not a specialist here for the hardware, so there should probably be subsections here, which I haven't made yet. And do you still hear me, actually? Yeah, okay. And then we have a software section where I have made 3 subsections. One is called object tracking, then one is called object classification, and then one for the graphical user interface. And then I would have another section which is called system performance, and that is a section where we actually have some results, maybe initial results, and how our system performs, and where we can define some parameters with which we can define how well our station tracks objects and how well it can identify like known objects and so on. And this would have a subsection on object tracking, where we define the performance of our simple tracker, basically. And I've just written some keywords here, what I'd be interested in. So, for example, fraction of detected objects versus ground truth. And ground truth, I would say, would need to be based on human observations, basically of
Material.
like
Video
live
images.
streams of our system, where we say, okay, you observe this live stream for, I don't know, 2 hours and check, how many objects are flying there on the video and how many of these are actually tracked by our system. So we would need to do that for I don't know how many hours, and define this fraction. I think that would be one parameter that describes our simple tracker performance. Then maybe the number of simultaneously trackable objects. I think this is also important. And then also trackable object speeds, independence on distance, let's say, and maybe also the ability to capture erratic movements like 90-degree turns, or also, for example, nighttime objects that are blinking. So, this is
Or sudden
basically a
stops.
tough,
Yeah.
something like that. These are, I think, maybe more tough cases for our simple tracker. And then we would have a section on object classification, the image-based inference approach by Nicola, and then the kinematics approach, and how well
By
these
yourself.
are able to classify objects, like common objects like airplanes and so on. And then we would also, I think, need to have test cases, and there I think would be simulation would be a great feature, where we have where we use commonly described shapes of UAP and also commonly described accelerations, for example, in the simulation, and we check first of all, are these simulated objects tracked by the simple tracker, and secondly, are our classification models, do these objects are they classified into known objects or not? This is, I think, would be a very important test to show that described anomalies by observers, UAP observers, are they below the object classification thresholds that we define? So our models will output a confidence, how likely it is that this object is an airplane or a bird or whatever. And these simulated objects should be, of course, below the threshold for our models, So, it would maybe say, okay, it is only a 30% chance that this is a bird or a plane or whatever. And this would be below our predefined threshold of maybe 95% that it is a bird or a plane. And because this simulated object, is below the threshold, we would record it, rightly so. And this would be our test, basically, to show that our anomaly detection is actually working. And this is then followed by a project outlook. I've not specific thoughts about that right now, and then we would have a conclusion section and references, and that's basically it for now. So this is just a first suggestion how we could approach that, but you were saying now that Christian already has basically a paper, so
A text.
then or a text, yeah, and then we could think about if we want to incorporate that into this paper, or if we want to have make two papers out of that. This is just how I would do it, basically. Yeah.
I would say we make two of it, because the paper that I already have, in more or less.
Christian hear all of this, or is he still there?
Christian?
I'm here. Hi.
Can you hear him, Jannik?
Hello?
Jannik, you can hear Christian, or can you?
Yeah, I can hear him.
No, I can't hear Christian.
Okay, stop your streaming and maybe you jump
Oh,
out and
wait,
jump back in again. I had to several times.
I think now I'm here. I hear him. I think for whatever reason, I think during the last meeting or so, I muted him because there were some noises or so. I'm sorry.
Yeah, I was in the car. I'm sorry for
Oh,
that
okay,
too.
okay, that was it. Yeah.
Okay.
Okay.
I would say, no, I'm saying, I wouldn't say, I'm saying, the paper I created in, I think it was in 2020. I produced a paper how astronomical observations are done. I produce it for SkyHub, so I have to review it, and I think it's only 7 pages long and covers only 1/3 of what I wanted to say. Because it's different to what you wrote here, I would say let's make it 2 papers. This should be the first one, the general first one, because it tells the people what we are up to, what we achieved so far, and how our methods are. The other one, my one, is informs about how astronomical observations are done in the past and are done now and will be done in the future. And this is completely different to what our first paper like this should be. So thank you, Jannik, for the great work putting it up. We talked last year about using overleaf, and what you did here is it's very nice. I like it very much. So let's start with this paper, and so I have much more time for the other one. But this one is an important one, I would say, because it tells the people exactly what we are up to and how we are going to do it.
Yeah.
I think we need to speak also on data quality. I had a lot of discussions about that lately. And
Okay,
I think we need
so
to
would you
clarify
make
another
section or subsection somewhere?
Yeah.
It do you have a suggestion right now, so I can basically...
It should be one of the major topics, like system overview, or in-system overview.
I would say it's like system requirements.
Yeah.
So it's a derivative of that.
Okay, maybe I make a comment right here. Or something like that for later on, so we can think about it where we want to have it. And
so may I ask you, Jannik? So this what we discussed already is this is the first paper that settles our foundation for what we do, right? And the idea is that we have much more papers along the line of development, which are some already written, like Christian's and so forth. And I think David produced a lot of written stuff. Not necessarily everything has to go into the first paper. I think the first paper should be just a rough overview, and then with further on going into with papers, we go into details on data quality. Could be an own paper, you know.
Yeah, this paper should contain all the things that we already have thought of. Not that that they are already in place, but they are thought of as an initial paper.
Yeah. So this is our basic approach, where in my field, where we have maybe when we start approaching a new idea or whatever, that we have this kind of a general paper where we write about the fundamental stuff, let's say. And then we can use this also later on when we write on more specific topics to cite our general paper and say, okay, when we can basically refer back to that general paper to save us some work and say, okay, this was already described in this general paper, and if you want to have more general info, look into that paper, and that gives us freedom to write about more specific things in more detail, basically, later on.
Yeah, exactly.
Yeah.
Cool.
Okay, so
can I find it on Overleaf? Or do you need to show it to me?
When you send me your email, I can. Oh, I shouldn't show that. Can we cut that out?
No.
I can. Sorry.
No, go ahead.
Yeah, I can share it with you. You just need to send me your email address, and then I can share it with you, and then you can directly work
I'll
here.
do it right now.
Okay. Then you can also contribute here in the and write.
What I like about Overleaf is that I think up to, was it 256 people can contribute to one and to one at the same document in parallel. And because of this tracking changes section, nobody gets confused. And what they did, I learned about Overleaf, I think, in 2012, and they come a long way, but it's worth it. And they did a pretty amazing job to get LaTeX running over, let's say, the whole planet. And yeah, it's pretty nice.
Yeah, absolutely. So we have this history here. And so we have different versions that we can look into. We have how do I go back like that? We have track changes, so we see when anyone does some changes in the text, we can see that here basically.
I can do it right now, so you'll see that I can change something.
Yeah.
Let's say we do it here, and we say
I see something happening. Yeah, something happened here right now. Yeah, entering text.
Entering text.
Yeah, and then I could say, okay, I accept that. I would I never reject something here. I mean, and I don't know, Christian, can you accept and reject here? Do you see that for yourself also? That is something that would be nice to have. I would say that we all have the same rights, basically.
I can accept or reject, yes.
Yeah, okay. Yeah. That's good, I think. So we all have the same rights.
I can accept and reject my own text.
Yeah. I can do that too. Yeah.
Like this, I did it. Yeah.
All right.
Do you have history like Git?
It has a history here, and it also
has revisions. Yeah, I am writing a book on Overleaf right now.
Okay, and it also has a chat, by the way. So.
Cool.
Yeah, I think that's a nice feature too.
Yeah, it's really great what they did for what's it called, the method? Collaborative work.
Yeah.
So, and when you want to have basically the current manuscript as a PDF, you can just download it and
current version,
read through it.
So another thing that I think about like the requirements is also decentralization.
Okay. I can include it here as a.
And again, it's a derivative of data, and sharing the data and all of that.
Decentralization. Data sharing.
Oh.
Yes.
Okay. Yeah. All right. So. Everyone who wants to contribute, of course, can do that. So
And then wait, I have more. And then about contribution, that's also very important, and membership.
I think also a topic about robotic systems in real time. Maybe it's subject to software, kind of object tracking, and
yeah, that's in software. Yeah.
About
sorry, Richard. What was that?
Real time and robotics.
Okay.
Yeah, like why we selected ROS, like what is ROS? Or something short, not too long.
Yeah. Oh, you can write a deep paper afterwards and referring to this one.
Yes.
Yeah.
What we should include is a short section about optics. Not explaining how optics work, but more how we select optics. So we explain Rayleigh criterion and Nyquist chain.
Yes.
Because
should I have
about
a subsection here about optics in the theory?
In the hardware. In the theory, I would put it in the hardware section.
Oh, okay.
Yeah.
And since we already have a paper about that, we can just put it as a follow-up paper. Or a more detailed one.
Be subsection.
Yeah, we should not discuss compute, because that's still under research, I would say. But software very good, optics very good. And then, you spoke about like monitoring and health and stuff, right? I think there was something.
Should I make another section for that? Monitoring?
And simulation.
No, you had kinematics. But I guess, monitoring and simulation, that's part of reliability. I would say reliability.
Okay.
Okay.
Like that?
Yeah, but not in hardware.
Sorry.
I think it should be on the same level. You have hardware, software, and reliability.
Oh, okay. I can do that.
So may I propose? It's not that we shall work on it now. I guess when we sit here for 2 hours, we find 100 more interesting topics to add. It was only meant from Jannik to show us how we can streamline that within the Science Advisory Board, so that several scientists can work on the same paper, which is very easy with what we just saw. And I think the Science Advisory Board, I call it is already settled. We can add more people. So Ido, if you want to contribute in this, we could add you.
Yeah.
But you also have to work there. It's not just being there. Okay, you just have to meet with the others and write text. Would you? Would you be able to? I mean, I hope you would be.
I'll do my best.
Okay.
Okay, I'm going to send you an invite for this overleaf thing here.
Sounds good.
Okay.
It's not only about bullet dropping, okay?
All right, so I'm going to stop sharing now then. Okay.
Okay. So, Jannik, anything more from your side towards this streamlining process of creating papers?
I think that was everything concerning our papers. I have a small feature request concerning our GUI, but this is not related to our papers. This is more related to our model training, basically. We can talk about that later,
Okay.
I guess.
So we have two guests right now here. You see them as Igor and Yevgeny from the SRCAA Ukraine. They are from the SOND project, and they, I think, maybe. Can you hear me, by the way, Igor, Yevgeny? Can you hear me and understand me?
Yes, I can.
Great, cool. Igor as well? Okay, Igor might not be here now. Yevgeny, welcome here. I have to inform you, this session is now on record. We record this session and bring it on YouTube to make it public. If you have a concern with this, I can stop the recording if you want me to.
No, that's okay.
It's okay. Perfect, great. So as you can see, I don't know whether you know a lot about Sky 360 and what we do here, but as you have seen right now is that we are forming our science advisory board at the moment and creating platforms how to streamline the process and the creation of papers. You contacted us. I would rather suggest maybe Evgeny, Igor, you can introduce yourself if you want to. Sorry.
Okay, I'll start first.
All right.
I'm from Ukrainian Research Center ZOND, which is connected with the abnormal research. So as all of us in this conference. And I'm the technique from the center, so I make some electronic devices to provide the long-time monitoring of abnormal some things. It's devices which record many sensors to card, and then we use it to see the charts of changing the magnetic field, the pressure, the temperature, and many other parameters. So it's maybe all about me. And Igor, maybe you say something too?
Igor, you there? Igor? Okay. Yeah,
Now I'll call him by the phone. Maybe he just
he does not know that
left.
he's muted. Igor, you're muted. So, what you did not say, Evgeny, is, and I say it here, please correct me if I'm wrong, you are from the Kiev University of Astronomy, and you have two locations in Ukraine, and with these two locations you tracked and detected UAPs over Ukraine. Is this correct?
No, I'm not from the University of Astronomy. I am from the Kiev Polytechnic Institute by Igor Sikorsky.
Okay.
And about the tracking, I can say that we tracked the sky in one location. I made the hardware for it. It was Yablonivka Kiev region, and we made 3-point detection, but not from sky. We just tried to looking up for the abnormal near the ground, for geo abnormal. Maybe Igor will tell more. Now I'll try to call him by phone. Okay.
Okay. Okay. So, meanwhile, Anyone here that wants to update us on her work? Fabio, can you update us what you just did?
Hey everyone. Can you hear me?
Yeah, but
Yes.
you are broken somehow.
Can you hear me better now?
Yes, and we can see you.
Okay, perfect. So I've been working on several different fronts right now. I have a couple of updates. So first, I've been working together with Ozzy Joe and on his camera that's outside. So I've been able to set try different settings for the camera and also different algorithms, and so I can better enhance the image. So we can try to have a solution for not needing to go in with exposure of too high just to see things. I've been pretty successful and having exposure of like 250 or 300 milliseconds and being able to see stars and to see helicopters moving during the night, of course, and also a couple of more things. So I've been playing with different algorithms like gamma correction and also binning and things like these. But these are only suggestions on my side to try to better get a moving target at night. Mm-hmm. And because enhancing just enhancing the gain was getting us a lot of noise. Mm-hmm. When we're trying to cool the sensor, it's still getting us a lot of noise because we have to go with gains over 35 or things like these. And so it's giving too much noise and not a very good performance. Mm-hmm. I'm trying different algorithms and different techniques get us a good picture and also at least like a frame rate of 3 or 5 frames per second. So we could like track the ISS and things like these on the sky. Mm-hmm. I posted also on our channel. Let's see if I can picture there on the iScout channel what I could achieve with the. I got better than that I posted, but that one is pretty good. It's down the iSky channel. See if I can share it. Just a second.
Up.
Yeah, because everything's too slow here.
Up.
Because I'm running a lot of different things.
You're over.
Yeah. So I don't know if you'll be able to see it. Let me open on the browser here. Be able to see it, but
yes,
you can see we have a frame rate of pretty decent one. 0.5 milliseconds, and also we can see the sky, the stars. We can track things there. Mm-hmm. So I think on my point of view, that's a good compromise. But we are lowering the resolution here. It's 1/4 of the full 20 megapixel camera, because I'm doing a 2x2 binning. So I get the resolution divided by 4. Mm-hmm. Every 4 pixels, it counts just as 1 pixel. I just sum all the pixels together. Mm-hmm. It gives us a good picture, and I'm able. I was trying to do some videos, but I'm doing a lot of things at the same time. I could not. I will share it during the week, like things tracking over the screen here, night, and like planes and helicopters and. I'm working together with Ozzy to see if we can track the ISS. I tried today twice. I got in on the first time I was on the right time, but it was just too low on the horizon, and so it just went like here. The second time I got in, when I got in, it already passed over, so I missed it.
Okay.
So, but I'm working with him to get the ISS passing during the night, so to see if we are able to track it. I think yes, we'll be able to track it. And let me just go back to the Discord here. Okay, so that is what I'm trying to accomplish on trying to get the right parameters for us to work at night. Because during the day, everything is perfect.
Yeah.
Have we need no low exposure and have low gain, so have a pretty amazing picture, and we're able to do everything. But our problem is mainly at night. Okay. Well, the other thing that I'm working on is the ROS2 systems and the tracking. And that is giving me a lot of work, a lot of trouble also, because so you can see here my Orange Pi is at full. I'm running right now the tracking. Let me show you here. That's my office here. It's low because you see my hand here is raised, and I will just put a laser pointer on this here for you to see it's tracking. But it's very slow because I'm also streaming, so and the streaming and everything takes much more than everything else. Anyway, it's slow. It's slow. When I tried to use the full resolution, the 20 megapixel, it couldn't do it. It was just impossible. I tried with my other camera, that's a 6 megapixel. It was also very slow. And so right now I'm just resizing the picture to be able to just see something and track.
So, do you want to discuss it on the meeting right now, or do you want to take it offline and we can analyze the performance?
We can take it offline because we have a lot of things we have a lot of things to discuss there. Because since I'm mostly doing everything right now, so and Dan is also helping, but let me just go back to the meeting. Helping, but
no, but the question is the UI is running on top of on the Orange Pi.
No, I'm not running any UI. I'm just running the RQ2 image viewer.
Yeah, that's the UI.
Okay, yeah. So it's running, but that's taking. If I show you the system monitor, you show that it's taking very little process itself. The main problem.
That's what.
The main problem right now is the tracker.
The tracker.
Yeah, the tracker is the main problem. Yeah, we can discuss it later.
We discussed it. So, yeah.
So we are looking
at so we are looking at doing two things to identify the performance with the tracker. It's one we are going to do like stream to see maybe a direct pipeline outside of ROS2 to see if there is an issue that we need to configure ROS2 better, and another one is to do a pass through to see if it's the algorithms that are causing their performance.
I still have a lot of places to optimize, but one of the things that we still need to look out is the QoS of ROS2 also, because I'm using the default one. So if you could maybe optimize these, it would be much better also, of course. And I didn't check that. I didn't dive deep into it because it's right now I'm just writing a lot of codes just to try to have something.
So this kind of deadline in optimization, you do based on data that you record. So, like before that, there is no reason to. So that's why I want to have the ROS2, because I want to understand how the pipeline works and where are the bottlenecks.
Yeah, sure. I'm using
because
RQ2
once we have that, then I can understand the timing and everything on that. Before that, you'll pull some numbers out of nowhere.
Yeah, and the thing is, tracker itself, I already changed the tracker. We were using a different algorithm before. That's a CSRT. That's a very good algorithm, but it's a little bit slow. It gives us good performance, but I'm changed it to the EQT, I think, right now just to test it. It's much faster, but anyway, it's not fast enough to get a full resolution picture and when you go there. So I still have to investigate a lot of different things on the whole. But what I achieved just a second. What I achieved so far was converting all the Python code to C++. Everything that you saw here was in C++ directly compiled and in release mode and optimizations and things like this. So everything's already done.
Big thumbs up. Please, everyone, hold tight. This is a big thumbs up. Thank you very much, Fabio. This is a great work that you did. This conversion to C++.
But anyway, and the tracker and things like this was based on the code from Mike, and that was a very good code. I must say it was in Python, but it was an amazing. It was a good ground foundation for me to work on. Okay. It was very good. I have to mention it because Mike did an amazing job on putting the ROS 2 together. Right now I'm changing a lot of the things there because I'm putting some of the nodes together. That makes no sense for them to be separated because this node just takes information from this node and this information goes nowhere else. So it makes no sense just publishing information that it's just produce it here, use it here, and we only need the output from this other node. So it makes no sense just to publish something that we're not going to use anywhere else. So I'm doing a couple of these things, and also I'm separating the topics in a more sensible way. For instance, I'm separating the camera topics on Sky 360 camera, then all Sky camera, then the mask and the live view and things like this, because we might have in the future also the output from the camera from the telescope camera, so we'll be having two cameras there. So I'm just organizing it a little bit better for us to use in the future. And also that's it. And I'm right now, what I'm doing right now is in this is putting out the parameters available for everyone else to use. For instance, you'll be able to change all the parameters of the camera, like exposure, gain, if will enable an auto exposure or not, or want to change the white balance, we want to change the binning, we want to change the resolution, we'll be able to change everything on the camera using ROS 2 parameters. And I'll be doing the same with the other nodes, including profiling, including logging, and everything like this. I'm doing this right now because that's useful for me, because we'll be able to do a full loop and also a full feedback loop. So that's what I'm doing right now.
Cool.
Nice.
Great work, Fabio. Anyone who knows how hard work it is to transfer anything into C++ knows how much work you put in.
Yeah. ChatGPT helped a lot, I must say, but anyway, it's just it doesn't know much about the ROS ChatGPT and gets a lot of things wrong, and so. But anyway, it was a good start for some of the things because I didn't know ROS before starting doing all the conversion. Never played with ROS before, so it was at least the help for me to set up the environment. Because to set up the environment for C++ is completely different from Python. From Python, it's very easy. For C++, I have to make the CMake files with all the dependencies, and it's just a mess.
Yeah.
Until I have everything set up and the message compiling and everything compiled, and it was the most of the part was just that part, just to make it compile.
Yeah.
When I make it compile and link everything together, and now it's more the easy part that it's just C++ and that's easier for me. Not only configuring and setting CMake files and linking and everything. sometimes a mess.
Cool.
And for instance,
it.
for instance, ROS2 even uses an older version of OpenCV, so I have to uninstall the older version that it uses and recompile some of the things of ROS2 with our newer OpenCV, so we can use the newer features.
Hey, cool.
So yeah, so I had to do a couple of these things also, and so everything is done on the dev container, so it's just in opening and running, and it works. Yeah.
So you're saying you're working with the latest version of OpenCV right now?
Yeah, we are on the latest version of OpenCV, the 4.7. Yeah.
Cool. Cool.
So we are able to save videos in 16 bits, 8 bits, and things like this. So we are already working with 4.7 for a while.
Okay.
On the Sky360 lead. But to use it on ROS2, I had to recompile parts of the ROS2 code.
Okay.
Did you contribute?
No, I didn't contribute because it's just download the repository and then linking with the proper
Yeah.
OpenCV, the newer ones, and put in there. But I had to uninstall the version first, all the dev containers to compile, or else it will be running both of them and they create a mess.
Yeah.
It runs with the 4.5, parts runs with 4.7, and then it's some of the things didn't work. I spent like at least 4 days trying to figure out why it was not working. Then I figured out that it was just a linking problem.
Jesus.
Okay, cool.
That's a tough groundwork. Thanks again, Fabio.
No, that's good. Now we have to talk later, and we can discuss this offline or during the week about the optimization of the ROS2 and etc. How we can make the best use of we have the hardware that we have, so we can see our limitations, because we might face a wall on the limitation of the hardware, and then we have to figure out what we're going to do.
Get a better hardware.
Probably.
That's one option with the hammer.
And what I'm going to do also, there's another Orange Pi that Richard sent me arriving, because mine is just an 8 GB version that I got it on. I was the first one to get it. There is the 16 GB version coming, so I might be playing with both of them. So I might be generating the image and part of the code in one, and maybe the tracker on the other, just to see if both of them together can manage the workload.
Interesting.
Yeah, that's going to be interesting, given you're going to produce much more data than the gigabit.
Yeah, true. But that's the thing here. For instance, the tracker node only uses the image and the output from the blob detection. It's not that much things to transmit on the bandwidth on the network. Maybe we will be able to have something. Maybe, I don't know. I have to figure out. I see.
That's good.
One question, Fabio. It's technically possible to use several modules with several different resolutions. We not necessarily have to run with one resolution through all modules. Let's say the background subtractor working with the same resolution as the tracker, right?
Yeah, the background subtractor has to work with the same resolution as the tracker. That's true.
Does have to. It's a must.
It's a must, because how it works. The tracker gets the regions of interest. We get the blobs around it. So and the blobs are themselves its positions on the image.
Yeah.
Like from 50 to 200, 200. And that's based on the absolute of the image.
Yeah.
So we cannot work with resolution image from different resolutions sent to different places, or else we'll be having.
Not necessarily.
I could convert also the boxes. Yeah, I could do that also.
And you were saying last week, that the background subtracker is more performant on the high resolution than the tracker. The tracker needs much more process power.
The tracker needs more process power. Yes.
Yeah.
The tracker is a much more sophisticated algorithm.
Yeah.
It's an algorithm that gets the full image, then it gets the resolution, it gets the bounding boxes of the regions of interest, and then it checks if the same object or not that's moving. So it can continue tracking that object. It does a lot of different things. The background subtracker itself is just a very basic algorithm. Just compares a couple of images. It might be like it's 5, for instance. It's much lighter and it can work much better and much faster with high resolutions than the tracker itself.
Yeah. So my question would be, would it make sense to run the background subtractor, which is performant and which is the first one actually to see a change in the background or in the sky, to use this on a high res, and the outcome is a black and white image, isn't it? Which is then fed into the tracker.
No, what's fed into the tracker are just the bounding boxes.
The bounding boxes. Okay.
Yeah, where like for instance, we have this thing changing from here to here. Then only this thing here will be on the background on the BGS, and then we have a bounding box around it. We just send it to the tracker.
Yeah.
This very basic information we send to the tracker.
So actually, the tracker is not working with the image.
It's working with the image also. So
Why?
we send the image because it uses the image to compare the object. We send it to him.
What's the performance, the accuracy that you get from that?
It depends on the tracker itself, on the algorithm that we're using for the tracker. So CSRT, it's much it's better.
Look. I think differently, and here is why. Okay, if you get bounding boxes, the only thing we care about is, okay, if that bounding boxes are moving in a way that's interesting the telescope to slew. Okay.
At the end, yes.
I don't care to understand if it's an object, or what's the shape of it and all of that.
No, but
this is less important.
The tracker doesn't do it. But the thing is, the bounding boxes themselves are just the changes in an image. So that bounding boxes is telling me that on that region of the image something changed. That's it. But we have several bounding boxes on our image because we can have several things that change it on the image. The tracker is the one that gets that bounding boxes and compares with a previous bounding box and says, "Oh, that's the same object." Okay. Oh, but we need to classify these and to see if something that's of interest or not, because we cannot move the PTF for all the moving bounding boxes on the image, so that will be impossible. We'll have to see which one is important. We have to classify it, so to see if it's a plane or a bird. So yeah, and for these we have to also to read them. If it matters or not. I'm totally open to this discussion later on. So to remove the tracker itself, for me that's okay.
I don't think we need to remove it. We want to break it apart to smaller components, like small algorithms that has like think about it like almost deterministic input and output.
I get it.
Okay,
but
so then we can disable each one and see where are the performance and what we need to focus on.
Yeah, the thing with the tracker, the thing, just a second. The thing with the tracker
Yeah.
is because this field of the image viewer science, it's very studied. It's studied fully. We have like hundreds of different papers with hundreds of different algorithms on different tracking methods to use. So that's that's a field that's very studied, and we are already.
But think about it, that in the end of the day, is a set of functions that are folding, right? That's what the tracker does.
Yeah, we can discuss it.
Yeah,
we can discuss it
let's
later.
discuss it. Let's
No,
discuss it.
I am perfectly fine because I also have the access to the source code of most of the trackers because we are using OpenCV, and OpenCV is open.
No, it
source
will
code.
be super difficult. It will be super difficult like that to understand, where we have the performance issue. So if you break it apart, it's more isolated.
Yeah, I already created a class to do profiling of different parts of the code. That's what I use it to
Yeah,
make everything.
Do it to the ROS2 node.
No, yeah, that's what I'm doing right now.
Well,
Yeah.
I'll tell you the idea, because once it becomes a ROS2 node, and we identify the performance, and we say, okay, this we got, let's say 50 hertz or 20 hertz, whatever, right? Think about like the background subtraction. We can set up the quality of service for deadlines of 20 hertz or 50 hertz, or whatever. And now you get violations of that if something changes the performance of the algorithm. You immediately get alerts. And that's what's important, because now we can progress over time and improve the entire performance of the system. So when you introduce something new, okay, most likely that will be like boxed in not meeting the deadlines.
Sorry, can you repeat your last sentence? I did not understand what you mean.
Okay, think about it that we have 3 algorithms working together on the same image, right? You get the image and all of the algorithm working. Now, if we break it apart, now we can analyze and have a quality of service per algorithm. Okay.
Yeah.
And now I can say, okay, this algorithm I want, because it gives me 60% of what the tracker does.
Yeah.
I want to have more hertz of it.
Yeah.
The other one, I can actually relax a bit of the deadline, so it doesn't need all the frames, because right now all of them are looking at all the frames. Right? We can play with it, and that's what when you think about robotic system, that's what it allows you to do. It allows you to prioritize which algorithms are working heavily, which are more relaxed, okay, and allows you to analyze the timing of everything, the performance.
Mm-hmm. Yeah, that's what I said when I need someone to look at the QoS of the system, because right now, since I'm doing everything, so
to look at QoS, we need to break it apart, right? We need to break it apart to ROS nodes.
It's already breaking apart. The only thing that's the only problem right now is the tracker, and the tracker it's a black box.
Yeah. Okay.
Yeah.
All the other nodes are completely separated. So.
I don't. Sorry, Fabio. Is there a tracker, from your knowledge? Is there a tracker that only works on let's say, the vectors of bounding boxes, not on the content of an image? So that a tracker that only uses the output of the background subtractor and not doing its own evaluation. A very simple tracker.
I need help on this, because I just start looking at the tracking things now, because in the past I did the background speed tracker myself. That background speed tracker was done by me, and the blob detection was done by me, optimized to the fullest. So, but I just start looking at the tracker itself. I didn't dive deep into this. I just start looking at this and looking at different options, different algorithms that you have online. I was reading about it, but it's this subject itself is very broad.
Yeah.
And it's some uses different algorithms and different tracking methods and different blah blah blah, and I need someone like David or some other to look at the papers and help me tackle and understand which one would be best for us to use. I can get this tracker and optimize it. And get the source code, and I can optimize the source code for our own needs. But I need help on this. Either David or anyone else that wants to help on this will be amazing, because I'm just throwing balls right now.
Yeah, absolutely, sure. So Ido, just why I asked this? We were 20 years ago. We were working on a consumer behavior system where we have cameras on top on train stations, and we monitor over, let's say, 100 sensors. We monitor people, how they walk through the train station. And because people are much more than, let's say, birds and planes in the sky, so we have thousands of people in the same scenery. The problem that we had faced in these days was, of course, we didn't have background subtractor. 20 years ago, there was not the idea of such. We made our own. But the thing is, a tracker, something that tracks, was already in let's say, discussed in a lot of papers. But what we found out is that if you take a traditional tracker that works on images and has to verify whether an object is the same as the object before, let's say if you have, over several frames and paths of objects crisscross, the trackers that are now in play evaluate whether the object is still the same, or it switches the track.
But here is the thing. Okay, you don't need to do that as often.
Yes.
As understanding the the shape, and even understanding the shape. Once you have enough history, you can start relaxing the frequency of that, because most likely it's not going to change.
I'm not
so
talking
you put.
Go ahead.
No, so you put weights on each one, and you're relaxing the real-time system from observing it. Okay, you don't need to do the calculation like blind all the time. Like work hard on that.
So what our finding? Let's say our finding is 20 years ago. But
another thing. Just a second. More than that, today you also have neural network that you didn't have 20 years ago. And with neural network, it works very, very differently, because it's all about training the model, and then let the model do the work, and the model does it with very low.
But now you're talking about something that is not
computation.
In play. Yeah, but now you're talking about something that's not in play at the moment. We have classifiers, yes, but we do not have a tracker based on a neural network. So, just let me make this my point, please. What we did 20 years ago is to split that, to have a kind of a self-made background subtractor where we only see changes from frame to frame, and create those vectors, those bounding boxes, and do that on. We were working with 20 frames per second, which was reasonable for people walking, because people don't run that fast in public spaces. So 20 frames per second was reasonable. But when we split it, we created a tracker that is only based on vectors, not on image-wise. It did not make sense because when you have thousands of people in the same area, they can always crisscross. And it's very hard to track one person in a mass of a lot of hundreds others. So when we do it on a high frame rate, because the so-called background subtractor was high speed, we create vectors with the same high frames per second, and the accuracy for keeping track and not losing people or crisscrossing tracks was rather low. So we came certainly below the 5% of mismatches. But it increased the performance enormously. And my question is now, would it make sense to imply something similar? I'm not talking about neural network now. I'm talking about as it is discrete as it is at the moment. But to separate the background subtractor from the tracker and give the tracker only the vectors to track and not another image that he has to log into.
Yeah.
So you're looking at it too much serially, and I'm trying to tell you it's a neural network. Okay, it's a lot of different stuff that we need the data of everything and understand it. And when I speak about the neural network again, you had a component that you call the tracker, but the tracker that we have has several algorithms. Okay, each algorithm is in the end of the day is a single function that produces something. You can have many stuff looking at the image. Okay, what we don't know is what is the value of all of them looking at the image all the time. And we need to record that data, we need to understand that data, and we need to give that to a neural network. That's how you develop today. It's different, okay? You let the fine-tuning, you let the fine-tuning and come from the neural network as a feedback, okay? And eventually, hopefully, we get to the point that the neural network will decide the quality of service of everything, because it will know what is a better detection based on anomalies. And that's where we want to get to. We need to get into the game of detecting anomalies. Is it something that we can learn from? Is it important? Yes or no? Teach the model and continue. Okay, you know, the biggest abstraction creates a very good, you know, situational awareness. I agree with that. Okay, and we need to start publishing that and start recording that. Okay, but we need to do that with everything else as well, because we want to evaluate the algorithms. We did a lot of evaluation on very little data, but that I would say we did a lot of hard work of improving that without really understanding what we have. And we kind of got lost over there. I'm trying to bring you back to like basic mechanics of systems. Okay, you have great tools today. You have, you know, simulation, or whatever. Think about it more simple. Don't think about it. Actually, it's not a bit more simple. Don't think about it as a serial thing. Think about it as neurons being fired, and you know, from all these algorithms. And someone needs to make sense of all of that. Okay, and it will be us saying, hey, this is an anomaly, this is interesting, this is not. And design and giving the weight for each of the algorithms.
Yes, I understand, and you're totally right, and this is certainly the way to go. For the moment, I was just mentioning that the background subtracker is working on the image material, and the tracker is doing the same on the image material. And for me, this is 2 times the work, which is not necessary.
No, but that's not true. That's not true. Again, one of the algorithms, or maybe 2 of the algorithms, need the camera because need the image, because that's what the algorithm does. It worked out of the image. Okay, but the tracker is a group of different algorithms that Mike and David combined. It's not just one. Okay.
Yeah, but
they look at the vector mapping. Yeah, go ahead.
Let me just clarify that, Richard.
Yeah.
Tracker does not do the same thing as the background subtractor.
No, of course not.
It gets the output of the background subtractor, so it gets the image and also gets the bounding boxes. So it uses the bounding boxes on the image to get the image from there, and then see the awareness of that, the object or not, or anything like this. So, but it does not do background subtraction again.
No, of course not.
It does not do bounding boxes again. That's not how it works. But anyway, yeah, that's true. Then it creates vectors. It creates if it's moving in the direction it's moving, and if it's the same object or not, and a lot of information like this.
So Fabio, what's nice when we break it apart to like ROS nodes, right? If you remember RQT again, now we can go and look at the design of the system and see where are the bottlenecks. Because we will have a system diagram, right, with everything that is going on, and again, you see how difficult it is to communicate how the tracker works. But when you have a diagram that you don't even need to create, and it's mapping to your code, it's much easier to discuss it, and it's easier to understand also.
That's true, but I have to figure out how the tracker works, so I can figure out if we are able to separate it or not, because most of the trackers sometimes they are just.
No, you separate it by the data types that they process, and the data types become your messages.
But that's what we do right now. Yeah. What I'm doing. Yeah, that's true. Also, I totally agree with you. You're totally on the right track. That seems also like a vision for the future, and we have to set a vision for the alpha, or else we'll never release anything, because we are always aiming for something that's
better and better.
Better and better, and on the future, and utilizing neural networks and I can for me I had to stop everything and just start doing the neural networks and and so my point here is this: you're totally right. I totally get it, and I totally agree with you. But we need to set a target. To set a target for release.
Look, a tracker is something that is very complex. I think having it barely working for alpha is way more than enough. And I like to throw it out there. Do we really want to have the tracker as part of the alpha, or really focus on the backup subtraction to start? Because we are working on it. It's not that we're not, and we can always release like a newer, better feature later on. But the tracker needs a lot of work, and I would say I would vote that work is not related to alpha.
No, okay.
But I think we can break it apart for sure to all the nodes, but disabling those that are costing performance right now.
Yeah, because in the past, I don't remember if you guys remember, I already show you like an image of my window with the camera pointing outside and all the bounding boxes following the people there. Yeah. That's very easy to do. That's already done. That's not. I have it ready here, so it's okay.
Yeah.
The only thing that's taking a huge amount of that you take a huge amount of time is the tracker itself, and the classifier, and because we need a classifier to see if it's a plane, a bird, or a drone, or anything else, and that's it. We can try to work without a tracker, so we will not be able to see vectors if it's moving this direction or that direction, and just inputting the bounding boxes. Of course, I have to redimension to size the bounding boxes to the correct size to send to the classifier. Do that, and then just having maybe a result from the classifier saying, oh, that's unknown object, so okay, that's something that we want to track, and then just send that object to the tracker. So we could switch places. So like this, I thought that's a very good idea, right? Because we could switch places. I could send the image that I already have, the classifier tells me it's something that I want to track or not, and then I send to the tracker. Now I'm sending all the bounding boxes to the tracker, and the tracker is tracking 10 different objects at the image moving, and so it's very slow because it has to track all of them and to check off them, and that's a very tedious and slow process. If you want to focus
again,
on
I will try not to focus on dependency. Okay, the dependency that you have between nodes is only on the messages that they are publishing.
no, true, but that's how it works right now.
Yeah. Because think about, instead of changing the order, think about it.
No. Changing the order. I mean, it's just this exactly what you're saying. I'm not talking about a sequence. I'm just talking about right now that the tracker is getting the messages from the background subtractor and is using all the message from the background subtractor. So that makes no sense. What I'm saying is this. It's not, I'm not talking about a pipeline that's sequential. I'm talking about message. Okay, so the tracker right now uses all the message from the background subtractor, and we can change it. We can make it uses a different kind of message that comes from the classifier, for instance, or any other node that will classify things and tells the tracker which bounding boxes are important.
So I would say, okay, when you design a node with the messages, the message needs to be the minimum possible message that you need to deliver what you want to deliver. Okay, so so a node that needs to do something smart like the tracker can actually look at multiple messages with different frequencies, okay, and utilize, like, think about it like build internally like a matrix, and it will work with the matrix object with its own frequency. Does that make sense? So for me, the bounding boxes is one part of the matrix. The classification is another part of the matrix, right? The background subtraction is another. The background subtraction does that. The bounding, right? But you have all of these that eventually becomes the matrix, which is the internal representation of the tracker data of what it does, right? But it doesn't need to do it all together at once. It can relax it and receive smaller messages, and and those messages are doing the update because, for example, bounding boxes, most likely it's high frequency because those are important. The telescope eventually will need that. And whatever. Classification, that's something that is variable. It changes over time, and the weight is like constantly like moving until it becomes like stable, and then you don't really care about it. And you can say, you can even like unsubscribe from that event anymore, because the target is not even of interest, so there isn't even to continue with the tracking of it. You just need to know maybe a bit where it's going or whatever, but that's it. Not like real time, as we think about like an object that has interest, right?
So when you have several tracks in a certain time period, and you give them different frequencies, how?
You do it by prioritization. Priority is the most important thing that the tracker can do, or the output of the tracker can do. It needs to be a feedback for the tracker, because that's what allows the tracker to focus on what's important and what's not. Otherwise, you're just flying blind. Right? Think about it. I can't actually speak about that.
We're on record.
Yeah. I can't speak about that.
Yeah, leave it out.
No, but think about it like radars, right? When you deal with RF and you deal with a lot of plots, and now you need to fuse them. There is a tracker actually that does the fusion and create like targets from all of those plots, right? That's a very heavy, and that works only on vectors, by the way.
Yeah.
Sorry, only on vectors.
On vectors.
Nothing
right.
else.
Yes, right.
Right. And the vector must have a weight to it. Because and that can be a very simple matrix, because you have the vector, you have the angle, you have the speed, the velocity, right? And that's enough for you to understand. Okay, it goes a different direction or not, and I can change the weight, right?
Yeah, but still the tracker has to follow it, and otherwise it.
That's what the tracker does.
No, not exactly. Not exactly. If it moves away from you, then the tracker loses interest, right?
Yeah, but losing interest does not mean losing it, because losing it means that in the next frame that's a new event.
Again, I'm speaking about relaxing the time constraints, not on specific tracking. You can't track all the objects all at once, exactly as you said. You can't track all the peoples and everything. You're going to lose. So you need to figure out what your focus is on. And you do that by constantly prioritizing everything that you see. And those that have anomalies, you increase their weights for priority. Those that do not have a monotony, you relax it. And yeah, you might lose it, but you know what? That's reality. That's physics. If you want to get performance, that's the way.
I would say let's be there. So we need.
Well, we are getting there. I mean,
yeah.
We moved to C++. We are now breaking down the tracker to more nodes, right? And eventually, all of that, we will have a neural network that will look at it, figure something out, will put a feedback back in. It's all like small components. It's all like small functions that you write that are working together. That's what it's going to be. Okay, there is no other way to do that today.
Okay.
Fabio, did you say something?
I just said that for me it would be good to learn something new.
All right. So, guys, it's a quarter to the hour. I would say we stop talking about development issues. And I stop recording now because I think Yevgeny and Igor want to talk with us. And I don't think that's necessary to have that on record at the moment, right?
Okay.
Yeah, sounds
good. You agree? Okay. So I stop recording.